Hi everybody, this is the IB probability and set theory package, but we're at topic 2 now. This is expected value, okay? And we're just going to go through this explore together. Now I know a little bit of the detail here is obscured because of the video here. I just wanted to be able to see everything. A fair coin is tossed 4 times. The graph below shows the probability distribution for the number of heads here. Now what a probability distribution is, okay, it's when you're seeing all of the outcomes of a given experiment with their corresponding probabilities associated with them. So it's like a sample space. Okay, so this probability distribution here is essentially the sample space with probabilities. Okay, that's what we're looking at here. And anyway, that's what you see here. So 0, 1, 2, 3, 4 heads, and then the probabilities that go along with it. Now, when 4 coins are tossed, what is the expected number or mean number of heads? Now, a lot of this is very intuitive. Like, if you just think about it, if you're tossing 4 coins, you just think about it for a little bit, you know that there's a 50% chance that any given one of those coins is going to land heads. Okay? So if you've got 4 of them, you would expect, okay, without even thinking too much about it, that 2 of them would show up as heads. Okay? That's the expected value. Now, specifically, the way we get that is we've got 4 coins, and the probability of getting a head is a half. Now, we're going to see how this works in just a second here, but that's essentially what we're doing. Okay? Now, the next little bit here says, the table below shows the probability distribution for the number of heads, x, when a fair coin is tossed 4 times. So, here are the results. Here are their corresponding probabilities. And notice what we're going to do here is we're going to multiply these together. So, 0 times that probability, well, that's easy, that's just 0. 1 times 0.25 is 0.25. 2 times 0.375 is going to be 0.75. 3 times 0.25, okay, I hope that's clear, that's going to be 0.75. And 4 times, I'm just going to double check this, 0.0625, don't want to screw that one up, it's going to be 0.25. I could kind of see that coming, but I just wanted to double check. So yeah, when we multiply the probability by the result, this is what we're going to get here. Now, it says here that the last column of the table has not been filled in. Okay, we just did that. Done. Okay. The expected value, here we go. Now, maybe zoom in a little bit. Whoops, sorry. I'll zoom in a little bit more on this. Okay. The expected value, EX, can be calculated using the formula. Okay, and then we got this formula here. Now, this just means sum of. If you've never seen that before, that little symbol just means add them up. So we're going to add up all of the x times the probability of x. Okay, and then they give that to you. They explain that to you. So we're going to calculate the expected value when we toss the coin 4 times. Now, I'm just going to go through here and add. Now, just think of this. 0.25 and 0.25 is going to be 0.5. That's easy. 0.75 and 0.75 is 1.5 plus 0.5 is 2. The answer is 2. Okay? And so that's, you can see here that this actually corresponds quite nicely with what we would have guessed, or what we did guess a little bit earlier on.